4/10 of a meter below the surface, and from about 5/10 of a meter to about 5/10 of a meter off the bottom, we're seeing the velocities in that zone. Yeah.
Yeah, terrific.
So,
you know, they got sodars. You've heard of sodars pointed up this way to do wind speeds.
Right. Yeah.
And it's,
Yeah.
you know, it's more or less diameter.
Yeah. So we're getting the velocity relative to the bottom.
Yes.
And Jim, can you explain the equipment just briefly once again?
Okay, so we're measuring the velocities with it's an acoustic Doppler curve profiler, and it profiles the velocity from about a meter beneath the surface to about 5/10 of a meter above the surface. So continuously, essentially once every second, we're getting a profile of the velocity. And what it gives us is the velocity relative to the ship. And so we have to subtract out that ship velocity to get the water velocity, and to do that, it tracks the bottom. So if the bottom is within the beam range, it's acoustic, you will get the actual water velocity. Now, to get the positions, we also have a GPS. I brought my own GPS board. The antenna's right up there. So we have the GPS positions fed into the program that's declaring the velocity. So when I get back into my office, then I'll plot everything up on a navigation chart so we can see how the velocities and how the tidal energy varies as a function of position going around the point.
Great.
Anyway.
I hope you don't mind me just capturing
very
this.
compendious and concise. You know what I mean? You got it all in and you kept it short.
Yeah. Well, you know, you have to give talks. You have to your scientific talks have to be 12 minutes, and so you get very, very good.
It's like a mega
and not
soundbite.
running on and on and on.
And by the way, my aunt had a hernia last week. Right?
Yeah.
You leave that out.
Yeah, exactly.
Yeah.
So where are some of the other exciting places you visited? I know you've done...
Okay. Well, as far as the tidal energy goes, we really have three sites that we're concentrating on. Hull is one, the Cape Cod Canal near Taylor Point, which is the location of the Mass Maritime Academy, is another, and the third is in Wiscasset, near the town of Wiscasset, the Sheepscot Estuary, which is where actually I did my graduate thesis, looking at the circulation of that estuary and how radionuclides discharged from the power plant. There was a nuclear power plant there until 2005. How that was carried by the circulation and taken up by the sediment. So it's an area kind of dear to my heart because I started my career there. We're also doing a study of the transport of mercury in the Penobscot River. There was a company which has since gone out of business, but the parent company is actually funding this work of how the mercury, to what extent the mercury has been taken up in the bottom sediment, and what the mechanisms are that get it into the sediment, wherever it's located in the sediment. Doing work in the Red Sea, looking at the dynamics of flows over the tops of corals in the Red Sea. Also looking at the exchange of various properties between the Gulf Stream and coastal currents, which all interact in the area near Cape Hatteras. And I was talking about this study, also looking at the transport of carbon from the productive coastal areas to the deep sea and how that fits into the global carbon cycle. So those are the sorts of studies that I'm involved with now. A couple more, but that's enough.